I have one.
I got another pencil. Okay, if you're just joining us, we're starting with the shell method today. We technically have 2 days set aside, though I don't think it's gonna take us 2 days to do shell method, maybe an extra practice to see if that eraser's good, it feels kinda hard. Here's how shell works, or
No,
you-
that's,
is it
just
okay?
makes it worse.
You're crappy? Okay.
Yeah, oh well, I'll be fine. I just won't make a mistake.
There you go, no mistakes in here. The benefits of the shell method, it lets you, sometimes it will remedy the problem of having to break something up into multiple sections. But what it's most useful for is switching variables. If you're going around the x-axis, instead of using x values, you get to use y's.
So like in this problem, you can use X as you know you're going Y, instead of
Correct.
having to solve for it.
Very
That's-
good,
that-
all right,
that'd be
yeah.
disgusting.
So in this case, our example here is f of x, here's the zone that's important from 0 to 1. And we want to take this area and spin it around the y-axis to create like a Hershey's Kiss kind of thing, okay? So that's, or bell, dome cap, whatever. I always think Hershey's Kiss on this problem. So yeah, Michael's already pointed out the first real problem. I can see that it goes from 0 to 1. If I'm doing y values, it's technically going from this 0 to this 1, so the volume, pretty straightforward. It would be a disk method, first off, because there's no gap in between there. So we do pi from 0 to 1, this 0 to this 1, because it's y. And then we hit a roadblock. Because I'm supposed to be able to solve this for y. And this equation right here does not look like it's going to be solved for y very nicely. If it were, it would have to factor beautifully. I mean beautifully, and this one does not even close, okay? So we're stuck, unless we ask the calculator, but even then the calculator has an issue because you have to type something in there, so nice try. So enter the shell method. Here's how shells work. With all of our other, I should have put cross sections, I'll have to add that. With all of our other volumes, we basically look at the area of one slice and then we add all those slices up. This is the one slice part, and then the integral is us adding it all up. So we have to rethink how we're going to slice it. This is what I love about shell. Okay, so imagine the other side of this thing. Picture the other half of it. If we were to spin it around, it's going to kind of come down here like this.
It looks like a little dome thing that I would imagine being like India or something.
Right. Okay, so imagine the other piece of it looking something similar to that.
I don't have enough room to draw that.
That's
Or
okay.
it,
That's
or it
perfectly
does look like
fine.
a Hershey Kiss.
Here's how we're going to slice it. Instead of doing cuts like this and making circles, do you know what those Russian nesting dolls are?
Yes.
Have you ever seen those? I can't remember the actual Russian word, but the
Iron.
nesting dolls,
The nesting dolls?
where you
These
open up
little
one
thingies
doll
here, yeah.
and then you,
Now I'm looking it up.
yes,
Just
I think
these
it starts
little
with an
thingies.
M, but I can't remember what word.
I know what you're talking about.
Mold, blah, blah, blah.
Blah, blah,
I'm just gonna
blah.
type in Russian dolls. and
Yeah,
see.
we'll have to wait till Abdul gets here.
Matrozakon. That word.
Might be that, yeah.
It's that word, but I don't know how to say it.
Anyway, we'll call them
These
nesting
little
dolls.
thingies.
Right, those things, where you open it up and one's inside the other. That's kind of the idea. So, here's how we're gonna create our
That
way.
lasers. Okay,
Oh.
bless you.
Yeah, that makes sense.
Matryoshka.
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 Paul's here while we look.
Matryoshka.
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 Hold on.
Matryoshka.
I couldn't pronounce that.
I have a Russian girl over at Green Tea, I should ask her how to do it.
I got you.
All right, you ready? Here's how we're gonna slice it. Not like this,
Bam.
not like that. That's classic,
That's classic.
old school, okay? We're gonna slice it like this.
Bam.
Ooh.
Oh,
Oh, no, we're getting fancy.
Okay, wait, watch. Yeah, I know, right? What?
I don't, what's?
But I don't get it. Okay, now I'm gonna take that and I'm gonna spin it around the y-axis.
Wait,
Okay.
what? Okay.
This is how you say it, you guys. Wait,
I see.
Okay? So that would be what one slice looks like, and then I'll come over a little bit more.
Matryoshka.
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 Matryoshka. Yeah.
Another one like
The
that.
tongue twister.
Oh. Okay. So we're just,
So we're making Middle Russian now.
Correct. Okay? And then we would do, it's like a paper towel roll,
I get it.
bigger and bigger versions kind of stacked on top of each other.
Like a toilet paper roll and
Cool.
a towel roll.
Very good, yeah. All right, so that's the idea, and then we'd start with a really tall one here.
The wrapping paper roll.
Yeah, anything, insert word here, roll, yeah, that thing, okay. Toilet paper, paper towels, wrapping paper,
Other words.
whatever, roll, okay. And this is the shape we get, so in the middle, it would be a very tall and skinny one, and the further you got out here, it would be a really, really wide but flat one here. Okay. So here's how any of our volumes work. From A to B of whatever the area of one slice is. Okay, so now we have to think for a second. First, what is the slice? And second, what is its area?
Okay, so we're doing cylinder.
Good. So the slices are going to be cylinders. What about the cylinder though? It's not the entire cylinder.
Oh yeah, because it's the hole in it. So large. So it's just these like circle.
it's this,
Kind of, yeah, we call it the lateral surface area.
Yeah.
Think about a soup can and you're cutting the label off.
so the surface area.
Lateral surface area. If you say surface area, you're including the caps.
Yeah, we just want,
The lateral, just the label of a can,
yeah.
okay?
That's,
Pretty straightforward. So all I need now is what is,
so it's
2 pi
circumference
RH.
times height.
very good, look at you, well, let's Google.
Circumference times
All
height.
right. So we're gonna be using the lateral surface area, which in this case, if you're gonna roll, it's a rectangle, length times width, or for a cylinder, the length would be the circumference, so 2 pi r h. There's our big A of x for this problem, 2 pi r
Which makes sense.
h. Okay, so nice try,
You're fine.
okay?
Aw.
2 pi from A to B, R, H. Ladies and gentlemen,
Ta-da.
the shell formula, okay? Shell formula.
I like this. Are we always gonna use the same shape?
Yep, it's always a cylinder.
Okay.
Okay.
It's like, well,
But look at how gorgeous that is. We're going around the y-axis, but what determines what the radius is of this thing?
the radius is the-
What determines the radius?
The X value.
The x value, not the y value, okay?
Ooh.
So in this case, the radius is x. What is my height going to be?
Y.
Y value
Makes
sense.
of that x value. So typically written,
This goes along with my way of thinking. I like this. I don't have to like contort my.
correct, okay? But notice, even though it's got x's in it, this is really going around the y-axis, okay? But it allows us to rethink how we slice it so that we can use the x values instead of the y values. And again, I will caution using f of x in our general formula because the radius might not be just the x value and the height might not be just the y value, but think of it like that, we'll do some harder ones in a second. Okay, so for this problem, for this particular example, and this radius, again, for our diagram, is the x value, and then this y value, or h, is gonna be the height of the function value. Once again, I will tout the glory of this, that we did not have to switch to y's, we could stick at x's the entire time. So, for this example, my volume will be 2 pi. Now, these are x intervals, not y intervals, but x intervals. In this case, it is still 0 to 1, but it's a different 0 to 1. It is this 0 to 1, not this 0 to 1. Radius r, which is going to be x. Height f of x. So 1 minus 2x plus 3x squared minus 2x cubed. Ladies and gentlemen, there you go. Okay, just for the sake of completeness, we'll go ahead and do one of these together, and then for the most part, we'll just skip to our calculators for this. All right, you get comfortable
This
here.
is literally same thing as disk, except we're just.
Which is the same thing as washer, which is the same thing as cross section. Area of a slice. It's just
We're just thinking
instead of
of
slicing it this way, we're slicing it this way.
We're just thinking of different shapes to use.
Correct. We're using those little biscuit cutters.
Yeah.
That's how we're doing it. We're creating slices like that. All right, let's see here. I would go ahead and multiply this out. X minus 2x squared plus 3x cubed minus 2x to the fourth, which makes all of my previously nice integrals turn into not quite so nice integrals. All right, antiderivative is going to be 1/2 x squared minus 2/3 x cubed plus 4 x to the fourth minus 2/5 x to the fifth, which is just plain annoying. The only saving grace about this problem is that we're going from 0 to 1. Both of those are great numbers to use. All right. We got that. Don't forget your 2 pi. Okay, here we go. The 0 is going to give me 0, so all I need to do is plug in 1. 1/2 minus 2/3 plus 3/4 minus 2/5 minus 0. Way down here. All right. Ah, crap. Okay, common denominator. 60? Really? 60. All right. So common denominator is going to be 60. Okay, that's going to be 30. That's going to be 40. That's going to be 60. What is that? 15? 45. Yeah, 45. And 12, 24. I hate it when the numbers aren't centered on the fraction. It bothers me. Okay, let's see here. That's 5. That's 6. So we get 11 over 60. The 60 will cancel with the 2 pi, so I'm going to get 11 pi
Over 30.
over 30.
Ew.
And if you type that in your calculator, we should be able to confirm that that's the answer. Well, the answer is kind of cool in all this. The neat part about this one is that formula. How we did not have to switch to y's at all. We could stick in x's. How awesome is that? Okay.
So really, just, so pretty much it's your, you just add, it's 2 pi to your x times your function.
Hopefully. Now, it is this if we're going around the y-axis and if this is always on top.
Yeah.
If not, then we may have to subtract to get a height, or if we're going around a different axis as our radius might change.
Yeah.
Here are common mistakes. Number 1, forgetting the 2 pi. Or putting only pi because you're confusing it with one of the other formulas.
Ooh.
Okay, so be careful. Sometimes kids also look at this and say, okay, you're doing the old double trick, where you take half and double, you know? Where we can do that on this one, this is not half and double, this is the actual formula, so don't forget that. Also, for some reason, people forget to put the x for the radius. They just do the function value and then forget that there's a radius involved. That's a pretty good picture, by the way.
I tried. I couldn't fit all of it, but I got the cylinders.
Pretty good, like half of a little cylinder.
Well, it's like, it's there.
Hey, all right, you got the first one, yeah, that's pretty good.
Well, I got the first two. I got the two cylinders. I couldn't do the other side though. Couldn't do the mirror image.
Okay, shall we try another?
Yes.
All right, it's not like you have a choice or anything.
I know.
We'll try another. Ooh,
Ooh, is it fancy?
I think so. I like to think so. Okay. Okay, let's pick a good one. Okay. I do like that one. It's one color. Okay. So here's our region. And the area is going to be trapped between f of x equals x times 5 minus x, and g of x is equal to, that works, 8 minus x, 5 minus x. Pulling this one straight from the book, I don't really know why they worded it that way. And let's spin this one about the y-axis. Again, anytime you see the axis you don't want to be going around, think shell. However, y is not always bad. If they've given me the functions and, not functions, but if they've given me the equations in terms of y already, think disc and washer. Okay, don't make it harder than what it needs to be. Okay, thoughts?
So, if I just do shell on the top, on the AP test, are they gonna be like, what happened?
Nope, it is a perfectly valid way. They even have it on their answer key. If a kid does it this way, that's just mathematically sound.
Because it is.
Because it is, yeah, it is. It's not technically part of the curriculum, but it
Someone
works.
teach it.
It works, you know. This, I don't know if you, when Sloan came in, we were working on a couple of problems. There was one in particular, an antiderivative that you could have done with his technique called partial fractions. And you could have done it a different way with the technique y'all know with U sub. And if it were an A-B test and you did partial fractions, it would be perfectly fine because it's mathematically valid, even though it's not in your curriculum.
Not your fault that you.
But you learned more than you needed to do, yeah. Okay, so if you're looking at the graphs of this, graphs of these things, we have this parabola down here. The first one looks like this. And that. Second one looks like this. Okay, and I'll just leave it to you to know how to graph these things,
Reminds
or
me of
not,
fish.
whatever. Here's what the two functions actually look like. Here's f, and here is g. Again, I don't know if you realize this, but from your last week's quest, when they give you these area volume problems, they tend to go ahead and draw the picture for you. Even though it is a calculator question, they'll go ahead and give you a picture of what's going on, so you don't have to worry about that. So here's the zone, and we're going around the y-axis.
Which is the zone? That thing, okay, that thing.
Right? Everything else is unbounded from there. So what I have to do now is decide on the method.
Stop. No, if the pencil kept rolling away, so I told her to stop.
disc doesn't work at all.
Correct, because there's a gap. The washer would. Here's the thing with washer though. If we're going around y-axis, we have to change everything to y's, which is not that hard to do with x's, okay? We can do it with squares. But we would have to do this. We'd have to split it here.
And then,
And then we'd actually have to split it here and here, because we'd have to do top function, bottom function for this piece, and then top function, bottom function for that piece. So we'd have to split this into
4 pieces.
4 different pieces with 2 separate integrals. Or we could do, if you know there's symmetry, which there is, you could do maybe the bottom half of it and then double it to get the top half. You cannot do the left half and double it to get the right half. Do you understand why? Do y'all understand why the top and the bottom half, when I spin them, are the same, but the left and the right half, when I spin them, are not the same? Do you understand why? I'd be really impressed if y'all can explain that.
So,
If I were to spin this like so, around the y-axis, the top half would be equal to the bottom half. But the left half spun is not the same as the right half spun.
because it's inner and outer, like it's kind of like a racetrack. It's like the outer track is longer than the inner track.
Right, it has further to go. So this piece on the inside has less that it needs to spin than what the outside does, so the volumes of those 2 pieces would not be the same. Top and bottom half, however, would be the same. Does that make sense?
If they were
So-
equal.
Which they are, in this case they are, alright. Be very careful when you're trying to do the half double thing, that you're actually taking half of the region and not some made up version that you wanna do. I'm gonna go with shell though on this one, because I don't feel like splitting it into 4 different pieces. Okie dokie. Volume, 2 pi, A to B, R, H. Which part would you like to tackle first? A to B or R and H? Okay. Excellent, I see where you're going with
What was the question?
that. Which one would you like to do first? Starting, stopping points, or radius and height?
Oh, fast.
Starting and stopping points, okay. If I'm going to leave this in terms of x's, then I need to know what this is, and I need to know what that is.
Sections.
Which really won't be that bad if we set f and g equal to each other.
Nice, yeah. It's because the
And you just kind of decide how you want to tackle that. I'd bring this to the other side, I'd get, well, you're probably going to have to multiply it out at some point anyway. 5x minus x squared is equal to 8 minus 5x plus x squared. I'm going to get 2x squared minus 10x plus 8 equals 0. Factor out a 2, x squared minus 5x plus 4 equals 0. X minus 1, x minus 4. So these things meet at 1 and 4. So it would be my interval from 1 to 4. Okay, what is the radius? Now let me draw a random slice. Okay, so here would be a typical shell. Cut it right there, and we're going to spin that little chunk around. Okay, so you get that particular shape there. And then I might slice it here and get a bigger one going around, slice it down here to get a tiny one going around. What is the radius of that shell?
the radius of that shell,
Or the radius of any
8,
shell.
x. Radius.
Whatever x value you decide to stop at. Okay? And notice, this is actually cool because it's telling you your x's only go from 1 to 4, which means my radii are only going to go from 1 to 4, so it makes sense. This interval tells me where my radii will start and stop, where it's actually going to, in this particular picture. All right? So the radius will be x. What is the height going to be?
1,
You'll need to be good at this by now, this is not rocket science.
So it's the, top function would be, how would you,
Just
what would be?
It's just top function minus bottom function is all.
Well, what
Okay?
is the top function of the same function?
What
Like,
do you mean?
aren't you splitting the function in half?
No need to, because as I look at this entire picture, that parabola is always on top, that parabola is always on bottom. I'm not looking at it sideways.
Okay.
Again, my height is here, and when I look at my heights, this function is always on top, this one is always on bottom. So it'll be f minus g. All right, f minus g. Two pi r h. Also, not that anybody was thinking this, and I hate to put it in your head, another common mistake is to square. These are the formulas that get squared, this one is not. This is the only reason that I feel a little reluctant to teach you shell method is because y'all done a good job of these, and I don't want you confusing the formulas. These are very similar, they're basically the same formula. This one is different enough, but close enough that you might think you've done something wrong, so be careful. Okay, from here it is old school, 2 pi. And while we're working it out, one of y'all crunch this in the calculator to see what kind of answer you get. Don't tell us, and we'll see how close we get to the right answer. 1 to 4 of x times, all right. We're gonna have 5x minus x squared minus 8 plus, no wait, minus 8 minus 5x plus x squared.
Yeah.
Trying to keep my pluses and minuses straight. 2 pi from 1 to 4. Okay. Crap. Okay, negative x squared is negative 2x squared. 5x plus 5x makes 10x. And then minus 8. I think I did that right. For a grand total of 2 pi from 1 to 4 of negative 2x cubed plus 10x squared minus 8x. There really isn't that great a way to do these unless you distribute it. And woe be unto us if this isn't a polynomial. If I've got an x out front tacked on to a sign or something, that's gotta be calculator or a different technique. Which for us is calculator. Alright, 2 pi. 4, negative 1/2 x to the 4th plus 10/3 x to the 3rd minus 4x squared from, where am I going, 1 to 4. Alright, get my algebra position here, 2 pi. This one's going to be slightly more irritating because we don't have a 0 in it. 4. Alright, 4 to the 4th is 256, divided by 2 is 128, I think. 64, 640 over 3. 64 minus, then we're going to stick in 1 and get negative 1/2 plus 10/3 minus 4. Okay. Okay, let's gather up all of our good numbers. We got negative 128, negative 64 makes negative 192, I think. So yeah, negative 192 plus 4 makes negative 188. All right, then we've got a positive 1/2
And a
630.
over 3.
Oh, 630 over 3 is
Which is-
210.
Yeah.
All right, so we get, what is this? 12, 22? Is that 22?
Yes.
12, that's 10, 22. So 22 and a half or 45 halves. So 2 pi times 45 over 2 for a grand total of 45 pi. Check myself.
We just had enough room.
Planned that perfectly. didn't I?
Yes, you did. I was hoping, like, I hope this is not the goal.
You know what I find to be the most irritating thing about this class?
I ran out of paper.
I love calculus.
You should
Basically,
start
this
off
is
with
this is the only
calculus
line of
and
calculus we did right here.
All of
This
that.
is all algebra, that's all algebra, there's the one line of calculus that we did.
Can you just do all calculus?
I know, it would be great if we could. Oh man, I guess we had to know some calculus and how to set the problem up, but even then, that's just a geometry formula.
There we go. You really did plan this perfectly.
I did, yeah. On your paper?
Yeah.
Alright, I got one more example on what happens
That
if we're
won't fit on
going,
the paper.
we'll have to use another paper.
Man,
Sorry.
I don't know, I kinda don't want to. I did pretty good with this sheet. It looks pretty.
Well, good. Okay. This is an example of what happens if we're going around an axis that is not the y-axis. Now, I technically have two other examples. I'm not gonna show you one because that definitely will not show up on the AP. Shell also works going around the x-axis. It's just typically, we like x's, and if we're going around the x-axis with shell, we'd have to switch everything to y's. The only time I would do that is if they gave me the example already set up in terms of y. So, for the A/B test, shell is really only good if you're going around the y-axis and you don't want to. Okay. All right, last example of the day. Okay, here's your zone. Let me write area. Here's your area. Y equals 1 over the square root of x. Y equals 0. X equals 1. X equals 4. So there's the zone. And I'm going to rotate this around or about the the line x equals -3. So it's not x-axis or y-axis, but it is parallel to one of those. Okay? I'm going to come over here and give you a crude sketch of what's going on. All right. 1 over the square root of x is going to look something like this. Kind of curves down like this. It does have an asymptote at 0 here and at 0 here.